Alright, so the last one I'm going to do is a hyperbola where the center is not at 0, 0. And again, it's pretty easy to pull off here. Because again, this is, if you're imagining x minus h, y minus k, so it's really going to be the values here, just in opposite. So since that's a positive 3, h is negative 3. Since that's a negative 2, k is positive 2. So we have a center at negative 3, positive 2, which of course is going to change our graph, how we do our graph a little bit. So now we need to identify our a and our b, which that's a squared since it's associated with the first term. That's b squared. Now since the x term is the one that's in front this time, we're going to have a graph that looks more like this as opposed to the last one where we had that look more like this. Okay, so again, if a squared is 16, that means a is plus or minus 4, and then b squared, if that's equal to 9, then b is equal to plus or minus 3. So from here, we need to identify our equations for our asymptotes. This can be a little tricky when our center is not at 0, 0. So if you look in your book on page 608, it gives you the equations for the asymptotes. They look a little gnarly, but it's really just plugging and chugging numbers. So if we look at those, since we've got the x value first, therefore our equation for our asymptote, okay, so that's what the equation for our asymptote looks like. We're just going to plug in the values we know, which we know what h and k are, we know what b and a are, so y is going to be plus and minus. So b was 3, a was 4, and then we have x, and then minus h, so that's going to be minus a negative 3, so plus 3. You can really just kind of pull off what's written there. And then plus k, so k was 2. Alright, and so you could either multiply all this out and simplify it a little bit. That's unnecessary. You could just plug this into the equation editor in Microsoft as it is, and it should graph it okay. So again, you'll have your asymptotes are going to be this positive, and then this whole thing being negative. So you'll have this line, and then the same thing, only negative. Okay. All right, so let's go over to graphing. Okay, so I've already put in my asymptotes, which if you're going to do this by hand, you're just graphing those lines like you would anything else. Pick random values for x and then solve for y, or vice versa. I've just decided to sketch them in and save a little time because hopefully you guys are comfortable with graphing lines at this point. So from here, again, my center of my graph is right here. So that a value that I identified, which from the previous screen, the a value was plus or minus 4. So a plus or minus 4. Now since the x term came first, the graph is going to open in this direction. So I need to identify my vertices based on where my center is. Now again, the center was at negative 3, 2. So, and since this is an x opening graph, I'm going to add and subtract the 4 from my x value for my center. So I'm going to add 4 to it, so negative 3 plus 4, one of the vertices is at 1. Negative 3 minus 4, the other one is at 7. So since I've got my asymptotes in, I know it opens this direction, therefore my parabola, I'm sorry, I keep calling it that, my hyperbola will look like this. Okay, and so again, then to identify the other pieces of the problem that they're looking for, they want domain and range. So with this problem, we have the flip issue that we had with the other one. In this problem, y is going to be able to take on any possible value. If you extend this off and either direction, you'll be able to have the full range of y values. Therefore, the range is negative infinity to infinity. But for this graph, we have a hole in our x values. Right in here, there is no graph. There are no points on the graph for these x values here. So now, again, we have a two-part domain. So the domain can be anything from -7 that way and anything from 1 that way. So the domain can go from negative infinity up to -7, or can go from 1 off to infinity. Okay, so, and again, that was our center. Our vertices, if you look at where they are on the graph, sorry, I know I've scribbled all this one, all the heck, but our vertices, we have one at x is 1, y is 2, and then we have another one at where x is -7 and y is 2. And then, of course, the last part of the problem is determining the foci, which, again, for these problems, that's c squared equals a squared plus b squared. So a squared was 16, b squared was 9, which, of course, is 25. So, hey, hooray, for the first time we have a foci with a nice even value, because c squared equaling 25 means that c is plus or minus 5. So those would be relatively easy ones to graph, because again, this depends on whether your graph is opening in the x direction or in the y direction. So you're just going to add this to your center, particularly whichever value you're opening towards. So since this is an x-centered graph, we will add and subtract 5 from that. So we would have a foci point at -3 plus 5, or 2, and then we would have another one at -3 minus 5, or 8. But again, you don't have to graph these. I'm perfectly satisfied with just coming up with the values for the foci. All right, that's it, guys. So if you actually made it this far, congratulations. I mean, in the video, I'm sure obviously all of you have made it this far in the class. It's been a pleasure having you here, and I hope to have all of you in classes of mine in the future. Good luck at Midstate.